Okay, welcome to the second part of our interview with Mr. Jeremiah Kiplagat. And Jeremiah is director at the Institute of Energy Studies and Research and has led efforts in building local expertise in renewable energy, digitalization, and sustainable utility practices. In this part, we will explore funding, challenges in this sector, and lessons from his journey. Jeremiah, welcome back.
Thank you. Thank you very much.
So what do you think, is any need for a large-scale project in smart metering? And is funding generally secured for existing or planned smart metering projects, either through government budgets or public-private partnership models, or support from international financial institutions such as African Development Bank, World Bank, and others?
Thank you. Yes, I think, as I mentioned, and that moving to smart meters is a must-do going forward, because we are able to interact with the customer better, know how to serve the customer better, and also, importantly, check how power is used, be able to trace, or rather check where there are losses and focus on that, because loss reduction is a critical thing for us to do, and we are on a roadmap to bring that those losses to a single digit in the near future. And so smart meters are very critical. As I mentioned, funding, we get our funding mainly for new connections. We have government support through last mile. Mm-hmm. And this is where government takes loans on our behalf, and then they own lend to us. Mm-hmm. For the low, what we call last mile. For the now customers, the commercial customers, they have to finance the connectivity. They pay because the tariff doesn't provide for it. Mm-hmm. So customers pay, then they are given designs, and then we connect them to power. After that, Kenya Power maintains those lines and those assets to ensure that the customers get reliable power moving forward. So for large-scale rollout of smart meters, it is a desirable thing, but we need to be sure what is the roadmap in terms of compatibility, in terms of what I talked of, communication, costs, and that it is sustainable, the technology as well, the various technologies that is involved. And also, for a large-scale rollout, you see, we have already invested. The customers have meters. So if you need to change in large scale, how will you finance that? Because the tariff doesn't finance it. Of course, we can do slowly through our savings, internal savings and all that, but that may not be able to cover that big rollout. So, but if it can be properly quantified, then a good business case is developed, then it can now accelerate and assist in decision making in terms of at what pace can we convert to smart meters. But in the past, the big rollout we did was funded by World Bank. Mm-hmm. I think we procured 60,000 meters and a meter management system. This is what we are using currently. And to scale forward now, we need to see issues of integration to ensure that we have a system which it can accommodate all kinds of meters effectively, and that management can be done effectively. I mean, the technical issues doesn't cause problems. So that is it. So, but for now, we are doing progressively replacing those failed meters with smart, and onboarding new customers with now smart meters. Yeah, thank you.
Okay, so we mentioned a lot of topics and a lot of issues about smart metering, but let's say like some summary, what are the key challenges you see in the implementation of smart meters in Kenya, and how can they be overcome?
Yeah, I think I already mentioned about the communication, the cost of communication. If you are to convert, I think currently we pay about, I don't have the exact figure, but about 30 or 40 or maybe almost 50 shillings per meter, but perhaps more per month for the communication that we pay to telcos. So if you calculate now for if we have to do 8,000, 9,000 customers, that will be a huge cost, which again, is not provided in the tariff. So how do you really manage that sustainably? So we must look at cheaper options of communication. And I think that issue of PLC communication or improved PLC with concentrators might be a better way, which can help us fast track that movement to smart meters. So one of the big problems is communication and the cost of communication. The other issue is interoperability. I think we have been looking at the issue of what we call the head-end devices that is compatible, because in our procurement system we don't limit any kind of meter. When you go to tender, anybody can win. You can have new suppliers supplying us with meters. We can have a variety of them, and how to ensure all these meters comply and are able to operate within this ecosystem. So that is that is also the assurance that we need going forward. And so this technology, they must be compatible properly, that is able to build accurately and operate accurately. So that is one of the gaps that we just need to close to enable us to now move better in the roadmap to smart metering and 100% smart metering.
Okay.
Yeah.
Tell me.
The other few, of course, capacity, which will always, there are new technologies coming up, and to ensure that we are well fast with, training our engineers. A lot of these require, to programming level, detailed engineering skills. So I think going forward, also we need to ensure that we improve our capacity to scale up the training of our engineers and those who manage meters, to ensure that they are able to cope very well. And also improve our capacity of data analytics. Because the essence of these meters will be generating huge data. How do we ensure that we are able to benefit from that? If you don't build a capacity for data analytics, then again, there will be no difference. We are not able to tell where losses are. So we need even automated systems which can do data analytics. So we will need to enhance that going forward to ensure that the smart metering initiatives are beneficial to the aspirations that we want as a company.
Do you see application of artificial intelligence tools for data analytics?
Yes, AI now is like the big thing, and actually we are looking at what do we need to do so that we are not left behind in AI. And I think going forward is going to play a critical role. Also, issues of security, cyber security and all that are critical to ensure that we are not exposed in any way, or our systems are exposed. So AI is an area that we must move, and using those AI equipment or other capabilities to analyze data is the way to go. And and we are very keen in building those capacities going forward.
Tell me, you mentioned net metering. So what is the situation with renewables in the residential sector? Do you have a lot of customers with solar panels on the roof?
Yes, because of the cost of solar has come down drastically. It's becoming very cheap, although solar with battery is still expensive. So what many customers is they put solar on their rooftops, and then they use now the grid for auxiliary services. That is because the objective is to reduce cost of power. So you find that in most cases they reduce up to 30-40% of their power consumption. And the trend on this captive solar is growing. A lot of customers are doing this. And so EPRA also has developed some regulation for net metering. Now we are working on how to implement them. So building capacity, we need to also to have a more smarter grid, because you'll have these solar panels are interacting with the grid. And we don't have visibility. There is need for visibility, for safety issues, and the like. So net metering, we are supporting. We are looking at a viable way where the grid is not very disadvantaged, but it is a sustainable model. I think we are working with the regulator to ensure that is achieved.
Do you expect any influence of the bigger number of customers with solar panels on smart metering? Do you see any relation about it?
Yeah, I think that's why these are some of the gaps. You need now a meter, I don't know what is it called, which can now measure what power is flowing in.
Okay, bidirectional.
Bidirectional meter, yes. You need a bidirectional meter. I don't think we have any at the moment in Kenya Power. If it is there, maybe some small demonstration project, but you see, those are the dynamics now going forward. That for net metering to happen, you need that bidirectional meter, and you need to build capacity on how that operates, so that you're able to net at the end of the month what is a surplus, either to the customer or to the grid. Yeah.
Yes, the question is, should you replace all meters with bidirectional smart meters, or go
I don't know, maybe from your experience, I don't know the cost of a bidirectional meter. It must be more expensive, definitely.
It always depends from the cost.
Than the ordinary meter.
Yeah.
So there will be cost implications.
Yeah.
But I think maybe for this, if a customer wants that net metering, then they might have to meet that cost of the meter to ensure that it's compliant. So as I mentioned, this is an ongoing discussion, and perhaps within a year or so, maybe everything will be in place. But we have teams now we are working on to ensure the success of that net metering. Yeah.
Okay, the same question for electric cars and electric vehicle chargers. What is the situation in Kenya, and do you see any influence on smart metering from that side?
Yeah, currently all the chargers, they are required to be on smart meters, because there is a electric vehicle tariff, charging tariff, of peak and off peak. It is 16 shillings during the peak, or rather, and half of that, 8 during the off peak. And we are encouraging vehicles to charge during the off peak at night, because we have excess power. So that meter should be able to tell that, so that we know which power is for peak and off peak. And I think a smart meter does that. So at least for now, we are making progress on that. All those customers who require to be metered for electric vehicles, they must be on smart meters. That's a requirement. Yeah.
Okay. And for the end of interview, What is the most important lesson you learned throughout your career? Some advice for young engineers.
I don't know. Maybe I limit to the what we are talking here, and I think in my past, what I think data is critical, and that decisions based on data, and that's why whenever we are designing projects, we must figure out how do we collect data so that we're able to monitor, we're able to assess performance, and see the success of a project, analyze deeper and see where the problems is and how to improve. So in some projects where we did without figuring that properly, you find that we are unable to assess the performance of a project and how to improve it, the impact. So as we design project, we need to have that in mind where we are making provision for data collection, and it is important for projects and success of projects. This is what I've learned, at least one.
Okay.
Yeah.
Okay, thank you for joining us, Jeremiah,
Yeah.
and sharing your experience and vision.
Yeah.
Your insights into education, innovation, and sustainability are valuable for anyone working in energy and utility transformations.
Yeah.
This concludes our interview. Stay with us for upcoming episodes where we will continue exploring key topics in smart energy, digitalization, and innovation.
Thank you. It's my pleasure, and I really appreciate this opportunity. Thank you so much.